Good day, I'm Martian Lester A. Duque from Team G. And today, we're going to talk about another renewable energy, which is the geothermal energy and hydropower energy that I'm going to discuss together with Janbian Mangalinaw and Mary Rose Nagayo. So let's start. So this is how it looks like this is how it looks like of a geothermal power plant. So what is geothermal power plant? So it is a used in order to generate electricity by the use of geothermal energy, which means the Earth's internal thermal energy. They essentially work the, the same as a coal, solar thermal, or a nuclear power plant. The main difference is being the heat source. So the working principles of a geothermal power plant is that uh, there is a natural source of power found below the surface of the Earth that has been around for centuries. Underground, far below us, there are pools of water heated by magma or molten rocks. These pools of water make up or make up our geothermal reservoir, harnessing the power of the Earth's temperature to power heat on cool our homes and business is the essence of geothermal power plant. So simply, it is the heat source or the heat below the earth around 2 to 3 kilometers deep, where is the heated water or the reservoir that is used in general power geothermal power plant, harnessing this heat source and taking the steam which is used to run the turbine so that the geothermal power plant produce electricity. So let's go to the ranking of the largest geothermal power plants worldwide as of this 2021 of January, in which the Philippines is in the top 4 of the largest geothermal power plants. First, we have the geysers from United States, Larderello in Italy, Cerro Prieto in Mexico, and here the Macban geothermal power plant, which is located in Laguna in Philippines. So next, so these are the top 10 geothermal countries installed capacity in megawatts around October 2018, which in total of 14,369 megawatts. So ayun po, pangatlo pa rin tayo in the largest geothermal power plant pag sama-sama yung mga thermal power plant in the country, in which the Philippines have a 1,868 megawatts that it produces. First pa din is the United States and second is the Indonesia. So this is how it looks like on the Macban Geothermal Power Plant, which is located in Laguna, Philippines. Next is the Geysers Geothermal Power Plant in United States. So the ideal locations on constructing geothermal power plant is that the most active geothermal resources are usually found along major tectonic plate boundaries where most volcanoes are located. So one of the most active geothermal areas in the world is called the Ring of Fire, which is encircle the Pacific Ocean. When magma near the Earth's surface, it hits ground the water trapped in porous rock or water running water running along the fractured rock surface and faults. Hydrothermal features have two common ingredients, which is the water the hydro and heat and thermal. So the geologists use various methods to find geothermal reservoirs. Drilling a well and testing the temperature deep underground is the most reliable method for locating a geothermal reservoir. So these reservoirs are deep underground and are largely undetectable above ground. Geothermal energy finds its way to Earth's surface in three ways. So we have the volcanoes and Puma holes, or the holes in the earth where volcanic gases are released, and hot spring geysers. So this is example of a locations in which we can construct geothermal power plant. The picture shows the hot spring. So the geysers is just like the uh, fountain or yung bumubulwak na tubig in which the water is uh, high, has a high temperature. So let's proceed to the types of geothermal power plant. Which first we have the dry steam power plant. So the working principles of a dry steam power plant is that dry steam plants are the most. So what is dry steam plants first? So it is the most common types of geothermal power plants, accounting for about half of the installed geothermal plants. They work by piping hot steams from underground reservoir directing into turbines from geothermal reservoirs, which power the generators to provide electricity. After powering the turbines, the steam condenses into water and is piped back into the earth via the injection well. So this is how the dry steam power plant works, in which they directly harness the steam, in which the steam kung saan yung steam is make the turbines run, and the excess steam will be condensated and become liquid, in which kung saan ibabalik pa nila ulit to uh, sa ilalim sa earth, and then after the turbine move, it will generate electricity. So this is another diagram in which how the dry steam power plant run. So in here, the pipe directly harness uh, steam, the steam, in which it move to the turbine that makes the turbine mm, run and generate electricity, in which the excess, kung saan yung sobrang steam, will be condensated on the condenser and put back again on the uh, injection tube, and babalik ulit siya sa earth. So the next slide will be discussed by Miss Nagayo.
Working principle, flash steam plants differ from dry steam because they pump hot water rather than steam directly to the surface. These steam plants pump hot water at a high pressure from below the earth into a flash tank on the surface. The flash tank is at a much lower temperature, causing the fluid to quickly flash into steam. The steam produced powers the turbines. The steam is cooled and condenses into water, where it is pumped back into the ground through the injection well. So ito yung example nung flash steam power plant. Hot water from underground is pumped into a uh, cooler temperature flash tank. The sudden change in temperature creates steam which powers the generator. So, ito yung mas malinaw na example ng flash steam power plant. Next naman natin is yung working principle binary cycle power plant. In these binary cycle plants, the main difference is that the water or steam from below the earth never comes in direct contact with the turbines. Instead, water from geothermal reservoirs is pumped through a heat exchanger where it hits a second liquid like isobutene, which boils at a lower temperature than water. This second liquid is heated into steam, which powers the turbines that drives a generator. The hot water from the earth is recycled into the earth through the injection well. And the second liquid is recycled through the turbine and back into the heat exchanger where it can be used again. So, ito yung example ng binary cycle power plant. Construction cost. The initial cost of geothermal power plant construction is high, but operational costs soon become relatively low. This means that even though geothermal energy becomes financially worthwhile, in the end, the cost of power plant construction may put geothermal energy out of the question. Compared to other renewal, in this binary cycle plant, the main difference is that the water or steam from below the earth never comes in direct contact with the turbines. Instead, water from the geothermal reservoirs is pumped through a heat exchanger where it hits a second liquid like isobutene, which boils at a lower temperature than water. The second liquid is heated into steam, which powers the turbines that drives a generator. The hot water from the earth is recycled into the earth through the injection well, and the second liquid is recycled through the turbine and back into the heat exchanger where it can be used again. Advantages. Some advantages of geothermal power includes is sustainability and consistency. Geothermal energy is renewable, so it's both more environmentally friendly and less susceptible to natural resources wars than fossil fuels are. Geothermal can consistently produce energy output 24/7, regardless of weather conditions or seasonal changes. Next is disadvantages. The disadvantages of geothermal power are the geographic limitation and high costs associated with power plant construction. This need to be built over regions with underground reservoirs of hot steam or water. Though it's technically possible to engineer enhanced geothermal system or EGS in unsuitable environment. It's highly impractical to do so. EGS requires extensive space, planning, construction, government oversight, and capital, and can only be accomplished by federal or state government and corporation. So next naman natin is yung hydroelectric power plant. Working principle. Hydropower plants capture the energy of falling water to generate electricity. A turbine converts the kinetic energy of falling water into mechanical energy. Then, a generator converts the mechanical energy from the turbine into electrical energy. So, sa next slides natin, dito natin makikita yung largest hydroelectric power plant.
So, next natin is yung list of largest hydroelectric power plant, which is we have the Three Gorges Dam found in China, Yangtze River, which installed a 22,500 megawatts. Next is the Itaipu Dam, which has 14,000 megawatts in Paraguay, Brazil. The Shilaudu, which has 13,860 megawatts in China. Belo Monte, that has 11,233 megawatts in Brazil. The Guri Dam, which has 10,235 megawatts found in Venezuela. Next, we have the Tacoroi which has 88,370 megawatts, found in Brazil, and in United States it has Gran Suli, which has 6,809 megawatts. Next, we have the Xiangyaba in China that has 6,448 megawatts. Next, we have the Longtan Dam, found also in China that has 6,426 megawatts. And lastly, we have the Sayano Shushen, Shushenskaya in Russia that has 6,400 megawatts. So the largest hydropower in the Philippines, we have the Magat Dam, which is one of the largest hydro facilities in Luzon with a maximum output of 38. Its construction of the dam started in 1975 and was completed in 1982. It is one of the largest dams in the Philippines. It is a multi-purpose dam which is used primarily for irrigating about 85,000 hectares or 210,000 acres of agricultural lands and power generation through the Magat Hydroelectric Power Plant. The dam is located within the boundaries of Namilingan, Alfonso Lista, Ifugao, and Ramon Isabela. Note that Ilihan Combined Cycle Power Plant and Suwal Power Plant is the largest in the Philippines with a generating capacity of 1,200 megawatts. Luzon Grid has a total capacity of 14,348 megawatts. Three Gorges Dam in China has a capacity of 22,500 megawatts. So, how it operates? So, we have the dam. Most hydropower plants rely on dam that holds back water, creating a large reservoir. Often, this reservoir is used as a recreational lake, such as Roosevelt at the Grand Coulee Dam in Washington State. The intake gates on the dam open and gravity pulls the water through the penstock, a pipeline that leads to the turbine. Water builds up pressure as it flows through this pipe. Next, we have the turbine. The water strikes and turns the large blade of the turbine, which is attached to a generator above it by way of shaft. Next, we have the generators. As the turbine blades turn, so do a series of magnets inside the generator. Giant magnets rotate past copper coils, producing alternating current, or AC, by moving electron. Next, we have the transformer. The transformer inside the powerhouse takes the AC and converts it to a higher voltage current. Power lines out of every power plant come two wires, the three phases of power being produced simultaneously, plus a neutral or ground common to all three. Next, the outflow. The use of water is carried through pipelines called tail races and re-enters the river downstream. So, on the pictures, this is shows the parts of the hydroelectric power plant. Next, this is how the water flows through the electric power plant and how it is uh, turns the turbine, in which how it creates a or produce an electricity. Next, we have the construction. So the constructions of these dams is difficult and labor intensive. The constructions begin, water is diverted or prevented from moving through the construction site. After the water is diverted, the foundation area is cleaned, excavated, and the rock or sediments that will act as a foundation are repaired and deemed solid. This is done to ensure the rock or sediments won't shift or fail as a result of the load of the dam and reservoir. And supports known as rock vaults may be used to strengthen the foundation. Above the dam, rock bolts and netting may be used to prevent rocks from falling on the dam. Forms are then built along the edges of the dam. Re- Rebar, rebar is placed inside, and concrete is pumped in. This is done in sections, and the concrete is poured bit by or is poured bit by bit in a block formation. Once enough of the dam is built, the reservoir is allowed to fill in high controlled manner. The dam is monitored during this process. Other structures that make the dam operational are then added. So the photo shows the designs of a hydropower dams. So there are main factors that can determine the dam's power output. First, we have the amount of electricity a hydropower plant produces. Depends on two factors. How far the water falls. The farther the water falls, the more power it has. Generally, the distance that the water falls depends on the size of the dam. The higher the dam, the further the water falls, and the more power it has. Scientists would say that the power of falling water is directly proportional to the distance it falls. In other words, water falling twice as much energy. Amount of water falling. So more water falling through the turbine will produce more power. The amount of water available depends on the amount of water flowing down the river. Bigger rivers have more flowing water and can produce more energy. Power is also di- Power is also directly proportional to river flow. A river with twice the amount of flowing water as another river can produce twice as much energy. So the tallest dam. So currently the tallest dam in the world is the Nurek Dam on the Vaksh River in Tajikistan. It is 984 feet, 300 meters tall. Hoover Dam is 726.4 feet or 221.3 meters tall. Today, Hoover Dam still ranks in the top 20 of the tallest dams in the world, but only in the concrete, gravity, and arc categories. So there are also dam failures. So we have the Bangjiao Dam in China, Henan, in which in 1975, the Bangjiao Dam failures, which causes 26,000 dead from flooding, over 145 dead from subsequent famine and epidemics, and 11 million homeless. Cost loss of generation, dam failed by overtopping in 1 in 2,000 years flood. Second, we have the Makchu Dam in India. The Makchu Dam's second co- jam second collapse leading to the deluge of the city of Marbi and the surrounding rural areas. 1 to 1,000 1,800 to 25,000 people were killed. Lastly, we have the Oroville Dam, which found in the United States in California. It damaged the spillway, caused evacuation of 180,000. So that's all. Thank you for watching and listening.